In this video, we're going to just do one big problem that's going to combine marginal cost, revenue, and profit. So let's read. A company's market research department recommends the manufacture and marketing of a new headphone. The research department presents the following price-demand equation. So X equals 10,000 minus 1,000 P, where X is the number of headphones that retailers are likely to buy at a price of P dollars per set. So again, P is denoted by lowercase p, and it's the price per X, not for the total price. Solve for price as a function of demand. Okay, because normally, remember, when we're looking at price, we normally want it as P of X equal. So we want P to be isolated. So we can do that pretty easily. We're going to subtract 10,000. It's just going to be the algebra part. And then we're going to divide by negative 1,000. Now that looks a little ugly. So what I'm going to do is I'm going to divide the negative 1,000 into each term. So I'm going to have P is equal to negative X over 1,000. And then I'm going to do negative 10,000 over negative 1,000, which is going to give me a positive 10. And so now this is a price in terms of X. So what I can actually do is I can call it P of X. All right, next part. Find the domain of the function defined by the price-demand equation. Okay, so I need to find values of X that can happen. Now remember that X is the number of headphones. So immediately, because X represents the number of headphones, you're going to be bounded by the fact that X has to be greater than or equal to 0. You can't have a negative amount of headphones. And then the other part that you need to use is you need to think about P. Well, P is your price, so P also has to be greater than or equal to 0. Because you're not giving money to people to buy a headphone. That doesn't sound like a very good business plan. So you're going to have X is greater than 0 and P is greater than 0. So what I can do is take the P, which I have right there squared off, negative X over 1,000 plus 10, this little guy right here, greater than or equal to 0. Right, so this part is P. And then solve for X. So I'm going to subtract 10. Multiply by 1,000. And then divide by negative 1. And in case you haven't seen this in a while, when you divide by a negative number, you change the sign, the inequality symbol. So it gives me less than or equal to 10,000. So what I have is that X has to be greater than or equal to 0 and X has to be less than or equal to 10,000. So my domain is 0 to 10,000. That's my X values that I can input into my price function. Okay. Next, the finance department provides the cost function C of X is equal to 7,000 plus 2X. Find and interpret the marginal cost function. Okay, so it tells us C prime, but we should know that marginal cost is C prime if it didn't give it to us. And the derivative of 7,000 is 0, and the derivative of 2X is 2. So very simple marginal cost. What does this mean? This means that for every unit, your cost changes by 2. So your rate of change is constant. Okay, it always increases by $2. So every time you make a new unit, it's going to cost you $2 more. So that's what that means, all right? The 7,000 is actually what is called the fixed cost. So 7,000 is fixed cost. That could be like the rent of the warehouse where you make the headphones or the salary of a manager, okay? So those are fixed costs, but every time you make a new headphone, it costs you $2 more. Okay, find the revenue of X and find its domain. Well, the revenue function is X times P of X. The number you're selling times the price you're selling it at. Well, we have P of X. I forgot it. Hold on. It was negative X over 1,000 plus 10 And so I'm going to put that into my revenue function. R of x is going to be x times negative x over 1,000 plus 10. And then I'm going to distribute the x. So that's going to give me negative x squared over 1,000 plus 10. Oh, 10x. Sorry, little 10. Didn't mean to leave you out. But this revenue function is going to have the exact same domain as your price function, because your price function is what made your revenue function. So the domain is still going to be 0 to 10,000. All right, next part. Find the marginal revenue at x equals 2,000, 5,000, and 7,000. Okay, so key word here is that we want to find marginal revenue. We have the revenue function. It's very easy for us to find marginal revenue. So we just need to take the derivative of the revenue function. Okay, algebraically, we have talked about this before, but let's remember. I'm going to do a little side note here. If you have negative x squared over 1,000, this is the same thing as negative 1 over 1,000 x squared. They mean the same thing, it's just that one of them has the 1,000 directly underneath the x squared, and the other one has the negative 1,000 as the coefficient in the front. But they mean exactly the same, because remember, x squared can be over 1, and then when you multiply the fractions, it gives you x squared over 1,000. So normally, people prefer negative 1,000 x squared to take the derivative. So when you bring down the 2, it's going to give you negative 2 over 1,000. X, subtract 1 from the top, it will give you 1. And the derivative of 10x is 10. So I can clean that up a little bit. Negative 1 over 500x plus 10. Okay, so now I want to find it at these values. So I would have r prime of 2,000. When you put that 2,000 into your handy dandy calculator, it will give you 6. R prime of 5,000 will give you 0. And r prime of 7,000 will give you negative 4. You can check that on your own. So what does this mean? This means that at 2,000 units, your revenue is increasing by $6. At 5,000 headphones, I should say, not units. We know what the units are. They're headphones. Your revenue is not changing. It's not increasing and it's not decreasing. Okay, so not, oops, sorry about that. Increasing or decreasing. You have no change in revenue. And at 7,000, you are decreasing. So that's bad. You don't want your revenue to be decreasing. So at 7,000 headphones, you might be making too many headphones. Perhaps you're making too many that are selling. All right. So you need to, we're going to see in the next one, a visual of what's happening in the revenue function. But this is bad. Okay. So at 2,000 was good because you're increasing. 0 is not so great. You're neither decreasing or increasing. And then 7,000 headphones, you're starting to decrease your revenue. So something pretty bad is happening here. Okay, find the intersection points of the cost and revenue function and interpret the results. So here are actually the graphs of the cost and revenue function. So the cost is the one in red. It was the linear function. It has a y-intercept of 7,000, which you can see when it crosses the y-axis, and it has a slope of 2. And then the revenue function is the one, the parabola. So negative x squared over 1,000 plus 10. And it's a downward facing parabola because the x squared is negative. Now, in terms of our function, right, the domain would only be 0 to 10,000. So you could actually kind of think about not here. They wouldn't be a part of the graph, okay? Because we only have 0 to 10,000. Now, where are the intersection points? Well, you can actually see them. I'll do them in green. It's here and here. But algebraically, the way that we can find that is by intersection, means that that's where they are equal to one another. They have the same point. So what we're going to do is, because this is, I don't want this 1,000 over x squared. So what I'm going to do is multiply both sides by 1,000. This is going to get rid of my 1,000 at the bottom there. So I'm going to multiply this side by 1,000. and multiply this side by 1,000. Remember that when you do this though, you got to, everything needs to be multiplied by 1,000. Okay, so you need to distribute it. So this is going to give me 1, 2, 3 plus 2,000x is equal to negative x squared plus 10,000. And then I'm going to bring everything to the left to make the x squared positive. So x squared plus 2,000x. And let's see how much I have here. In this situation right here, I have a really large number. So I'm going to have, oh, you know what I forgot? I did a little boo-boo. This needs an x here. So this is 10,000x. Apologies. Let's erase this. So this is going to give me, when I subtract, actually 8,000. And then plus, so let's see here. How much do I have? I have 7 million. So let's make sure I write all of the zeros. Is equal to 0. And I'm doing this by hand, but of course you can always check it with your calculator. And so this is actually going to factor nicely for us. This is going to be x, this is going to be x, and this is going to be 1,000, and this is going to be 7,000. And you can see that that will give you 6 zeros at the end for 7 million. So these are both minus, so at the end is positive and the middle is minus. So this will give me x is 1,000 and x is 7,000. And that matches pretty well, right? Here it is. 1,000, 7,000. So visually, it matches what we're getting in our factoring, all right? So you could also use the quadratic formula, but really, if you can, you know. So what does this mean? This is actually when the revenue is equal to the cost function. These x's are actually called the break-even points. It's when you will have no profit, all right? It will literally be when your revenue is just enough to cover your costs. So as you can see visually, at 7,000 is when you are starting to, something bad is starting to happen, okay? So you need to retrack your steps and do something different, okay? So 1,000 to 7,000 is your sweet spots for making your headphones. And actually your very, very sweet spot is where you're making the most amount of revenue there, right? With 25,000. So these, again, I'm going to highlight break-even points. Very important. And it makes sense. It's where you break even, right? Literally. Okay, so let's look at the profit function. So from last, we have profit is equal to revenue minus cost. My revenue function was negative x squared over 1,000 plus 10x. I'm not going to forget it this time. Minus, and don't forget to put your cost. My cost was 7,000 plus 2x. Maybe right before I go on, let me just make sure of that. Plus 10x. Looks good. Okay. So now I'm going to distribute my negative. So that's going to become negative 7,000 and negative 2x. And then I can combine like terms. I only have 2 like terms, which is the one with the x. And so that's going to become a positive 8x and a minus 7,000. So here's my profit function. And so I'm going to have the domain, and the domain is going to be the exact same domain as the revenue and the price. So 0 to 10,000. And the last question, use marginal analysis to estimate the profit of the 1,000 unit. So we have use marginal analysis to estimate. So first of all, because it's saying marginal analysis, we need to find the derivative. We already found the derivative of negative x squared over 1,000. It was negative 1 over 500x. The derivative of 8x is 8. And the derivative of minus 7,000 is 0. And then this is when it gets tricky. So let's see if you remember from the last video. Because I'm using marginal analysis to estimate the 1,000th unit, I need to do one less. I need to drive into the 1,000 unit. So I actually need to do 999. So negative 1 over 500 times 999 plus 8. So then you use your handy dandy calculator. And that is going to give us approximately $6. Okay, so the profit of the 1,000 unit is $6. So that's right. You should be making a profit because we saw at the break even point. So the 1,000 unit is literally when you're starting to make money, right? We saw that. So while you're making the 1,000 unit, you're just starting to make your money and you're making very little amount of money. You're making $6, but that will increase until you hit 7,000. Okay. So your profit, very small. It's okay. You're just starting to make money. And here it is.